Hey everyone, welcome to this explainer. Today, we're taking a step back, and I mean a massive planetary step back, to look at our home from the most awe-inspiring vantage point you can imagine, the orbital perspective. When we look down at our interconnected blue planet, what we see is this breathtakingly complex system of oceans and continents. But as we'll discover today, the neat little boundaries we draw on our maps, they don't always tell the whole story of how this world actually works. We're going to break down the composition of Earth's surface, explore some of the incredibly dynamic forces hidden beneath the waves, and take a hard look at the very real human footprint we're leaving behind. 75%. That's how much of our Earth's surface is covered in water, leaving just 25% as actual landmass. But this brings us to a fascinating problem known as the freshwater paradox. You see, despite this absolute mind-boggling abundance of water all around us, the vast majority of it is salty ocean water, which is completely unfit for land animals, including us. Freshwater actually makes up a remarkably tiny slice of that 75%. It's found only in our glaciers, rivers, lakes, the atmosphere, and underground. It is an incredibly fragile balance, and frankly, it's the core driver behind global water scarcity today. Okay, let's dive right into this. Here is our roadmap for today. 1. The orbital perspective. 2. Mapping oceans and continents. 3. Islands and frozen frontiers. 4. The power of tsunamis. And 5. Our collective responsibility. Section 1. The orbital perspective. Understanding Earth's geographic divide. Our planet is essentially defined by a tale of two very different hemispheres. Up top, the northern hemisphere is truly the terrestrial realm. This half of the globe contains the vast majority of the planet's continuous land masses. But when you look at the southern hemisphere, it's an entirely different story. This is the oceanic expanse. It's heavily dominated by this interconnected, continuous body of water, with the icy, isolated continent of Antarctica firmly anchored at the bottom. And ocean water doesn't really care about the lines we draw on our maps. It constantly flows right across those conventional boundaries. The oceans aren't neatly boxed in at all. They are one continuous expanse sustaining shared marine life all across the globe. And honestly, this isn't exactly a new realization. For instance, if you look at the emblem of the Indian Navy, it bears an ancient Vedic invocation to Varuna, honoring the traditional water deity. It just beautifully reflects humanity's deep, historical reverence for these vast, interconnected waters. Section 2. Mapping oceans and continents. Categorizing the globe. So this brings up an interesting question. What exactly defines a continent? Well, it isn't purely scientific. Take the Eurasian Divide, for example. If you ask geologists, they look at the tectonic plates and physical rock, and they see Europe and Asia as one single massive landmass, Eurasia. But historians and cultural experts, they separate them into two entirely distinct continents. So our maps are shaped just as much by human cultural evolution as they are by physical geography. Because of that human element, you might have actually seen models teaching that the Earth has 4, 5, or even 6 continents. The Olympic rings, for example, symbolize the 5 inhabited ones. However, the Magnificent Seven is by far the most widely adopted global standard. That 7-continent calculus gives us Africa, Antarctica, Asia, Australia, Europe, North America, and South America. All right, we have our continents. Now let's rank the ocean roster, the 5 major oceanic basins by size. We start with the Pacific Ocean, which is by far the largest and most dominant water body on Earth. Next up is the Atlantic Ocean, the second largest continuous basin. Third is the Indian Ocean, and what's unique here are its boundaries: Asia to the north, Africa to the west, Australia to the east, and the Southern Ocean below. It actually splits into the Arabian Sea and the Bay of Bengal. Finally, rounding out the roster, we have the Southern or Antarctic Oceans surrounding the icy South and the Arctic Ocean, which is the smallest basin sitting way up at the top of the world. Section 3. Islands and frozen frontiers, exploring specific fragments of land. First off, we need to define what an island actually is. It's basically a landmass completely surrounded by a sea or ocean. But to be an island, it must be significantly smaller than a continent. And the absolute largest island in the world is the global giant Greenland. To put its massive scale into perspective, to equal the size of Greenland, you would have to combine the total land area of the 10 largest states in India. It is literally a gigantic fragment of land. Speaking of India, let's zoom in on its specific geographic footprint. India actually possesses more than 1,300 small islands. It features 2 major island outposts. To the west, Located in the Arabian Sea, you have the Lakshadweep Islands. And to the east, in the Bay of Bengal, are the Andaman and Nicobar Islands. These outposts are totally crucial extensions of terrestrial geography, stretching right out into that vast continuous ocean we were just talking about. But humanity's reach extends even further, all the way down to the harshest, most isolated fragment of land on Earth, Antarctica. This frozen continent has a brutally cold climate, a harsh environment, and is almost entirely covered in ice. Yet, the Indian Antarctica program was initiated back in 1981 specifically to research climate evolution. By 1983, they established Dakshin Gangotri, India's very first scientific base station there. And what absolutely blows my mind is that over 40 Indian scientific teams have conducted research here, and they actually live in settlements that have a post office and a library sitting right in the middle of the ice. Section 4. The power of tsunamis, the dynamic and dangerous energy of the ocean. Now, what's really interesting here is how this immense dynamic energy actually works. Let's step systematically through the mechanics of a tsunami. It basically happens in 3 violent steps. Step 1 is the deep origin. A strong earthquake or volcanic eruption violently fractures the ocean floor. This triggers Step 2, energy displacement. Massive volumes of water are instantly displaced, sending incredibly powerful waves traveling at jet-like speeds over thousands of kilometers. Finally, Step 3 is the coastal impact. As that energy hits the shallower shore, the wave compresses, surges upward, and submerges coastal areas, causing widespread devastation. And as a quick aside here, the oceans also breed violent storms and cyclones through atmospheric interactions, just adding to their raw destructive power. Because these forces are so incredibly destructive, early detection is absolutely paramount. Fortunately, while destructive tsunamis are rare, we can now detect them before they actually hit the coast. The Indian Ocean Tsunami Warning System is this highly complex network that relies completely on multinational cooperation to protect lives and property. On the response side, in India, for example, the National Disaster Management Authority, or NDMA, is the institutional body tasked with jumping right into action to handle these extreme oceanic events the second a threat is detected. Section 5, our collective responsibility, the human footprint. Before we wrap up, we really need to remember exactly why saving the ocean matters so much. This isn't just about water. The ocean literally acts as the planet's lungs. Marine flora, specifically tiny algae and seaweeds, actually produce more than half of the world's oxygen. Think about that. The oceans are the primary regulator of our global climate, and they drive the vital water cycle we all rely on every single day. Plus, the marine biodiversity is just staggering. It's a rich ecosystem stretching from sunlit coral reefs all the way down to the mysterious dark depths, housing thousands of species, from dolphins to massive sperm whales. But here is the unfortunate reality of the human footprint. We're hitting the oceans from 2 massive human-made angles. On one side, we have pollution. Millions of tons of plastic waste are being thrown into the oceans annually, choking marine life and degrading the very biosphere that keeps us alive. On the other side, we have extraction. Overfishing, which is excessive commercial fishing, is causing a rapid, devastating decline in marine populations. Both of these activities undeniably present a severe threat. They directly threaten the ocean's ability to continue functioning as the planet's lungs and as our climate regulator. And this brings us to our conclusion. Every year on June 8th, the UN designates World Oceans Day to remind us of the ocean's vital role as our lungs, our food source, and our critical biosphere. It really is our collective responsibility to protect it. I want to leave you with this incredibly powerful quote from Jules Verne, written way back in 1870. "The globe began with the ocean, so to speak, and who knows if it will not end with it." Looking at the interconnected beauty of our blue planet and the incredibly fragile balance we hold in our hands today, what collective actions must we take to ensure we aren't the ones who bring that ending about? Thank you so much for joining me for this explainer. Until next time, keep learning and keep looking at the big picture.